What is the mechanism for bromine addition across the double bond? So that's bromination reaction. Bromine will add Br and Br across the double bond in anti-fashion. So we say it's anti-addition of Br and Br. Anti-addition results in the formation of trans product. So that means you have one bromine coming out and the other bromine going in. Mechanism. First, we will draw the Br2 as Br and Br. I'm differentiating them and you'll see why. The first step involves an alkene attack on the Br. So assume one side of the Br is an electrophile, positive charge, and the other side of the Br is a nucleophile with a negative charge. So remember, this is just the way you assume or visualize, not really positive or negative, but it makes it easier to understand the mechanism. The first step will involve a nucleophilic attack by the double bond because it has high electron density, and it's going to attack the bromine that looks like it's positive, so that's the electrophilic bromine. At the same time, the bromine has lone electron pairs, and those lone electrons will go back and attack the other carbon. So you end up with a cyclic addition. And at the same time, you break the bromine-bromine bond to make this bromine a negative charge. I'm drawing it like this because the bromine adds from one side. And because this bromine used its electron pair, now you end up with a formal positive charge on the bromine, and this is called bromonium ion. So that's step number one. Step number two, you use the bromonium ion and then plus the Br minus formed in the first step. This Br minus is a nucleophile for the second step, and it will attack the bromonium ion intermediate. Now the question is, where does it attack? Now let's look at that bromonium ion. It has two carbons, carbon number 1 and carbon number 2. If you look at carbon number 1, has two alkyl groups, so it has 1 and 2, making it look like a secondary carbocation. Carbon number 2 has only one alkyl group, making it look like a primary carbocation. We know that secondary carbocation is more stable than primary carbocation, and that means that a new group, the Br minus, the nucleophile, will add to this carbon that looks like a secondary carbocation to give. So when the Br adds, this will open up like that, and you end up with the pink bromine opening up like that, while the green bromine adds from the other end, the opposite end, giving you a trans product. And therefore this process is called anti-addition.